Hey folks, welcome to a new video. So in this video I want to discuss again about JavaScript arrays. In the last video I did discuss what we call or what we mostly use mostly use as an array in JavaScript is not actually an array, it's an object, right? So that was a bit real, but let's say if we actually want to get the behavior of arrays, or if you want to actually understand how an array is stored in memory and whatever so on, right? So how would we do that in JavaScript? So JavaScript has support for static type arrays, where you can define the type of the array, you can have a fixed length of it. So I want to just represent, or I want to just demonstrate how an actual array would behave and how it is stored in memory, and like how do you build that low level intuition of when you think of an array, what it should be or something as such, if that makes sense. So let's get started. Let's start with, let's say, const nums equals to new int 16 array, and make it 6, 9, 4, 2, 0. Yep, that's my favorite set of numbers. Now let's try to console log nums. So, and let's save this, and let's try node index.js. We get this. So it's an array of a fixed length where every element is of 16-bit. So every element that you see here is a 16-bit. It occupies 16-bit of space in the memory. So yeah. So basically this is 16-bit, this is 16-bit, this is 16-bit, 16. So total the size would be 16 to 5, which is, if I'm not wrong, 18. Like, yeah. So basically, so it's storing 80 bits, and yeah, so it's occupying 80 bits of memory in your RAM or something, basically, in a sequence. So how would you observe that? Let's say we do dot buffer. Okay, let's do dot buffer, and if we try to print it, we get this. So you see it's a bit very, like, it looks very weird, right? So it's mostly in hexadecimal notation, if you are aware of hexadecimal notation and stuff. So it's showing this is like a 16-bit integer, right? So it's a 16-bit, as mentioned here, in 16 array. It's a 16-bit integer. So ideally these are 8 and these are 4. So the on the inside is binary. So when I say 4-bit, it's like this is 4 zeros, this is combination of 1 and zeros, 4 blocks. If you want to know more about binary notation, you can understand that in some other video. There are plenty of those. This is like 4 zeros, 8 zeros, 8 bits of zeros, 1s and zeros. So that's how those are stored in memory, right? So now how are we getting these exact numbers, right? That begs the question, if everything is binary, how is it knowing that I need to represent the first 16 bits as one element, next 16 as one element, next 16 as one, because we are mentioning it as uint 16 array. So what we are essentially saying is, this is the block of memory, whatever elements are there, represent, take 16-bit as one single element and give me the output. So it's basically a point of perspective, right? So this perspective is of 16-bit array, 16-bit integer, sorry. And if we want to observe it in some other format, we can do that, right? So let's try that, right? Const num, let's say nums2 or something. What did I write? Nums2 or something. Then we do new float 64 array, and we pass nums.buffer. Now the magic will happen. So just be ready for it. Okay, now it won't happen. Now it will throw an error. Why? We'll come to that. Console log nums2, let's say. And if we try to print it, we got this is error, right? So it's saying that byte length of float 64 array should be a multiple of 8. So let's try to understand why is this happening. So what we essentially did was we had this here. So we had 16 bits of 5 elements of 16 bits, which is 80, right? But if we want to parse it as 64, we need 3 more elements here. let's say into 3 as in what would be that? Let's say we have this 1 2 3 4 5 6 7, one more 8. So now we can parse it, because understand the frame of reference, right? This is 16, this is 16 bit. Okay, so for it to be 64, you need 4 such spaces, right? 16 4 is 64. So what we essentially did initially was we told take this and parse it as 64, like float 64. So essentially four elements of a 16-bit array would result in one element of a 64-bit array. That's how it's observing, right? When you are taking binary. So let's see, this is an example. So what we did was, this is one element for this, but for float 64, this whole thing will be one element. Oh no, sorry, this whole thing 1 2 3 and 4 till here, right? So this issue is coming up because it's able to parse for the first it's able to parse till here, like it's able to do it till here, but here it's getting blocked because there is not enough space for it to allocate allocate the next closest block of memory, minimum memory that it would need to fit in the array in it, right? So I hope I was able to explain it, but like basically on the bottom line, to parse something as u in 16, you need one element will be this long. To parse something as float 64 or 64-bit, one should be 16 into 4, so this long. So it needs minimum this length in a buffer to parse those elements as, or parse, okay, let's use parse as a good word or whatever. So parse those elements as float 64, or to show them as float 64 or represent them as float 64, because it cannot represent this as float 64 because it doesn't have 64 bits after it, right? It has like how many? It has I think 16 bit, this is 16 bit. So it needs 64 bit to get the data and show it and represent it as float 64. So what we need to do is we need to let's make it how much? 1 2 3 4 5 6 7 8 elements. Now it will have 2 64 bits, 8 elements as in 16 into 4 into 2, which is 64 into 2. So 64 2 64-bit elements it has. Now let's see what it parses, right? See, we had what did we had initially? Console.log nums. Okay, we had this, and it's the same representation which is converted to this. Like that's what it's, right? So there is no absolute thing as such. It's just how you are observing the memory, from which lens you are observing the memory, right? On the core, it's storing everything as binary in memory, but depending on how you observe that block of data, it will show that output. So here you can see it had 8 elements. When we observed it from a perspective of a float 64 array, it has 2 elements, because 16, every element is 16, 16 4 is 64. So these resulted in this single element, and these 4 resulted in this single element. That's how it is. But at the core, an array is basically, as I said, a continuous block of memory, where you store your elements, and depending on how you observe it, you can get different results, right? So what this is essentially doing is converting that block of memory into a human readable form, and you define what human readable form you want. You can say, okay, consider 16-bit as one element and give me an array. So it will convert that into 16 blocks of 16 bits and give you an array. You are saying, okay, consider it as a 64-bit array, and 64-bit block will give me an element, and it's float. So you represent that and it will give it to you. But at the core, it's everything binary, and everything is a continuous block in memory. So yeah, that's what I wanted to explain in this video, and I hope it was clear. It's a bit complicated to understand, but if you are able to wrap the head around it, it's very easy to like understand and think about arrays and how they work in general, and like from the low level of it, right? So yeah, I think that should be it for this video. If you have any doubts, you can ask in the comments, or you can reach out to me on Twitter. And yeah, see you in the next video, guys. Bye folks, see ya.